Hello there. Let's go on to section 2 of chemistry. This is still unit 3. This is about compounds and bonding. There are your learning targets. Notice that number 6 says big target. We're going to spend a lot of time on this one. So turns out that elements in the periodic table don't usually exist by themselves very often. They have formed compounds and keep forming compounds, and there's thousands and thousands of different compounds. Basically, a compound is atoms of at least 2 different elements, if not a lot more, chemically combined. A good example of that is the compound called water, H2O. It has 2 atoms of hydrogen and 1 atom of oxygen. The little 2 is a subscript, and any subscript applies to just the element that it's to the right of. For example, this 2 is to the right of the H. This 2 only applies to the H, not to the O. There is a second number which can be written that you can put in front of the molecule, a large number called the coefficient, and it applies to everything in the compound. When we start balancing equations, we'll come back to that and explore that further. So it turns out when compounds are formed, they take on new chemical and physical properties. They have characteristics about them that the individual atoms did not have. So the atoms lose their properties and the compounds gain new properties. For example, hydrogen and oxygen are both gases. The elements, hydrogen and oxygen are both gases, but when they form, H2O becomes a liquid, a totally different property. The number and arrangement of electrons in an atom determines if it will combine to form compounds. So what this big bold bullet says is that the electrons are the key players in determining what atoms will come together to form compounds. So how do compounds form? They form in something called a chemical reaction. If you ever mix baking soda and vinegar together, you have formed a compound. You took 2 things separately and new compounds are formed. What holds a compound together is energy called chemical bonds. And we're going to explore 2 kinds of chemical bonds in this section of this unit. The first kind is called a covalent bond. The co means to share, and valent refers to a valence electron. So in the molecule H2O, the compound H2O, the 2 hydrogens and 1 oxygen are sharing electrons in order to be chemically combined. It turns out that valence electrons, which are just the outer level electrons, remember how we explored the first 3 levels? Well, however many electrons are in the outer level is the valence electrons, and bonding only involves them. All other electrons are not used. So here's an example of the water molecule. You can see it. In this case, it looks like Mickey Mouse turned upside down. Notice that the 2 electrons here, oops, didn't mean to click that. The 2 electrons here and the 2 electrons here are drawn side by side. They're not any different than these electrons. They're just being highlighted in red, and they are being shared. So here's a hydrogen atom, there's the other hydrogen atom, there's the oxygen atom. These 2 electrons are being shared between this hydrogen and oxygen. These 2 electrons are being shared between this hydrogen and oxygen. And this is what keeps the whole thing together. Here's a carbon dioxide molecule, CO2. Same thing, only this time it's going to share 2 pairs of electrons. Okay, so here's the carbon. Here are the 2 oxygens on the end. Each oxygen and the carbon shares 2 pairs of electrons, so 4 electrons total. And same thing over here. This is called a double covalent bond because there's 2 pairs being shared. Here's an atom molecule of the nitrogen molecule. I'm sorry, a model of the nitrogen molecule, and it's 78% of the gas we're breathing right now, and it shares 3 pairs of electrons in order to bond to form a compound. So this is not what it chooses to do, this is what it has to do before these 2 nitrogen atoms come together. They have to share 3 pair of electrons. So obviously this is called a triple covalent bond. So one pair being shared is single, 2 pairs being shared is a double, and 3 pairs being shared is a triple, and that's as far as it goes. It doesn't go any farther than that. Second kind of bonding that form compounds is called ionic bonding. Some outer level electrons and atoms are not stable, and they're so unstable that they will give up those electrons to become stable, or they'll receive electrons from nearby atoms to become stable. When an atom's electron number changes, whether it gives one away or takes one in, it becomes charged, because remember, electrons are negatively charged. A charged atom is now called an ion. So look at that definition right here. A charged atom is called an ion. One of the best examples of this is table salt, sodium chloride. A sodium atom, turns out, has one electron in its outer level. I'm going to show you this in class, and I'll show you a diagram of it too. And the chlorine atom has seven electrons in its outer level. It'd like to have one more. So when you combine them together, the sodium is going to give up its one electron, and chlorine is going to receive it. So when sodium gives up the electron, it becomes positive by one because it lost a negative. And when chlorine gains that one electron, it becomes negative by one because it gained an extra negative. So here's an example of that. So here's the sodium atom. It's got 2 electrons, 8 electrons, and 1 electron at the third level. Because it has 1 electron at the third level, it's very unstable. It will donate that to chlorine. Chlorine has 7, and to get that magic octet number of 8, it will take that 1 electron, and that results in 2 different ions, a positive ion and a negative ion. And that positive and negative opposite attraction is what holds the 2 things together to form the compound. So that force between the positive and the negative is the ionic bond. Notice that the electron energy levels do not overlap. Unlike in covalent bonding, you see that the electron levels overlap. That's the one big difference in a diagram to tell which kind of bonding it is. So you can take your time to read this down here. This walks you through the idea of the donating and the receiving of electrons and the changing of their names from sodium and chlorine to the sodium and chloride ions. Okay, that's it. See you next time.